Hey, what's good, teenagers? We are going to review basic trigonometry today. We're going to stick just to right triangles, the unit circle, angles, and we're going to do maybe one application problem. It shouldn't be too bad. Hopefully you live through it. But just in case not, you might want to go kiss your mom goodbye. Tell her you love her. Say, hey, Mom, you know what? I'm going to be back. I'm going on a rad math adventure. See you in about 30, 40, 50, maybe even 60 minutes. All right, let's go ahead and review trigonometry, shall we? We are going to start talking about measure of angles, just so we're 100% clear on the difference between the two. So degrees, these are the things that you've grown up learning and loving. This is when we cut the circle into 360 equal pieces, but you probably don't need me to review that. You're probably most familiar with these. They're pretty good. A lot of people use them. They're not too bad. Another way that we can measure angles is with radians. And radians, in case you forgot, is if instead of cutting it into 360 pieces, we take a circle. Let's even make it a purple circle. We take a circle. Remember where that center is. And we take a radius and then wrap this thing around. What we're going to do is measure how many radii around the circle we go. One length of this radius, however long it is, that equals 1 radian. In a full circle, there are 2 pi radians, or about 6.283 radii in a full circle. Cool. So most of the time you're going to be able to recognize radians because they're going to be like pi over 6, or it'll be some fraction with a pi in it. That's how you'll know. So now that we know these, let's talk about how do we convert between the two of them. So remember, there are 2 fractions. They're really the same fraction, just flipped upside down. And the way you get this is from knowing that there are 360 degrees per 2 pi radians, right? And then you just reduce this fraction and it turns into that fraction. So this is just a ratio, right? It's like miles per hour, right? It's just saying how many of these things there are in each of these things. So to convert from one to the other, we're going to multiply by one of these 2 fractions. The way you know which fraction to multiply by is whatever you currently have, that same unit should be on the bottom of the fraction you're multiplying by. So I currently have degrees for this 195 degrees. So I want to multiply by the fraction with the degrees in the bottom so that the degrees cancel out. So for fractions, you just multiply straight across. So we have 195 pi over 180. Then you want to put your coefficients or your integers into a calculator and just have your calculator reduce that for you. This reduces to 13 pi over 12. Shouldn't be too bad. If you want to go the other direction, right now we have radians here, and we want to turn those into degrees. The way I know this is in radians is because there's a pi right there. So because the pi is on the top in what I have, I want to use the fraction with the pi in the bottom so that the pi's cancel out. So we have pi over 12 times 180 over pi. The pi's cancel. So we have 180 divided by 12. Put this in your calculator and you get that pi over 12 is 15 degrees. Not too bad. All right. Let's talk about right triangles and trig operations. So when you are setting up a trig ratio, remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. These are 3 that you should have memorized because we used them a whole bunch in the other trig unit, unit 12. And they're just good to have memorized. Like, you're going to use them again when you go to college. If you're not going to college, then you're going to use them again in a few days when you take your final. So you got to remember them at least until then. It's good to be aware that there are reciprocal trig functions, which you've also seen. There's cosecant of theta is just the reciprocal of sine. So it would be the hypotenuse over the opposite. Secant is the reciprocal of cosine. So that would be hypotenuse over adjacent. And then cotangent of theta is the reciprocal of tangent. So it would be adjacent over opposite. When you are trying to figure out what side is opposite and adjacent, you want to look at which angle you're kind of referencing those sides from. To find the opposite side from this angle here, you start in the angle and you go straight out the middle, and then the side you run into, that would be your opposite side. Then the side that is directly across from the 90, that would be your hypotenuse. And then the only one left must be your adjacent side. Okay, cool. So there you go. I don't know that you necessarily need me to go over it. Here, let's make up a quick example, shall we? There's theta right there. That's theta. Let's say this is 5 and this is 2. What's tangent? It would be opposite, so we go straight across. This would be the opposite side. This would be the adjacent side. So tangent of theta would be 5 over 2. If we want to know that missing side, because this is a right triangle, we would just use the Pythagorean theorem. So it'd be 5 squared plus 2 squared equals c squared. So 25 plus 4 equals c squared. 29 is c squared. So c is the square root of 29. And of course we throw away the negative one because you can't have a negative length. Cool. Let's talk about inverse trig operations. Inverse trig operations are used to solve for an angle. And these are, it's not like you divide by sine or divide by cosine or something like that. This is the opposite in the same way that adding and subtracting are opposites, or rather inverses. So if we want to find this angle theta here, what you want to start by doing is setting up a trig ratio, one of these, with the information they give you. So we need to figure out, are these opposite, adjacent, or hypotenuse? Here's our right angle. So this is our hypotenuse. And this side 3 is directly across from the angle we're looking for. So this must be our opposite side. So we want to set up the trig ratio using the two sides that would be used in that trig ratio that we know. So the trig ratio that uses opposite and hypotenuse would be sine of theta. So sine of theta equals opposite over hypotenuse, 3 over 5. To get theta, what we need to do is do an inverse trig function to get rid of the sine operation off of this theta. So the inverse of sine, it doesn't have a nice name. It's just the inverse of sine. If you do it to one side of an equation, you have to do it to the other side of the equation. So the inverse of sine cancels the sine, and we get theta equals the inverse sine of 3 over 5. This thing, sometimes you'll know it if it's a nice one, like on your unit circle, but most of the time you won't. So this thing you will just type into a calculator. Usually on your calculator you'll have a sign button, and then right above it in a different color it'll have that. So you'll probably have to press like the shift button. Shift, there's here, shift there. And then that button, and it'll give you the inverse. So you do inverse sine of 3 over 5, and then your calculator will spit out an answer. In this case, theta is about 36.87 degrees. I rounded a little bit, but you're going to have to because it's going to give you an ugly decimal. Most of the time, they're not really nice answers. Cool. So there are inverse trig operations. Let's just discuss the unit circle. Kind of the expectation that I have of you guys is that you have this like 80% memorized, right? You should definitely know some tricks to be able to fill it out. If I gave you 5 minutes and a blank one of these, you should be able to fill out the whole thing. Some important things to know. All these middle ones are, I would call them 45-degree angles. They're 45 degrees from either axis. Those are always going to be pi over 4s. And the ordered pairs are always made of radical 2 over 2s. Sometimes positives, sometimes negatives. You should be able to tell if the x will be positive or negative based on what quadrant you're in. This is positive, positive, negative for x, positive for y, both negative in the third quadrant, and then positive x, negative y in the fourth quadrant. So that'll tell you which ones will be positive and negative. And you should know that sine tells you the y piece of these ordered pairs. Cosine tells you the x piece. Cool. So there's some stuff about your unit circle. Yeah, you should have it memorized. It's useful. It helps you get answers very quickly. Use it. At the very least, have it sitting around so that when they say, what's the inverse sine of 1/2, you know that you want to look for the 1/2 in the y position. Oh, look, there it is. It must be 30 degrees. It could also be 150 degrees, but probably not if you're looking at a right triangle, because if you have 90 here, 180 minus 90, there's only 90 more degrees that it could be. So it has to be the small one, right? So there's your unit circle. It's useful. You should have it memorized. It looks nice. Maybe get a tattoo of it. Ask your mom really nicely, Mom, please, can I have a tattoo of the unit circle? It's really sweet. I bet you I'd get tons of the gender I prefer if you let me have one. And then she'll say, no, mija or mijo, no smooching until you're married. All right, let's talk about finding the exact value of some trig ratios. I believe this was the 4th lesson in the unit. Basically what they're going to do is they're going to give you an angle, not necessarily on the unit circle. Because these are bigger than 1, the unit circle probably looks more like that. But, you know. So we want to be able to find any of these 6 trig ratios for these angles. So first thing we need to know is we need to turn this angle into a right triangle by dropping a straight line from the terminal side endpoint down to, or maybe up to, if it looks more like that. Draw from the terminal endpoint to the nearest x-axis to make a right triangle. Once you do that, realize that x and y are telling you the length of the x side and the y side. Whoops, back up. Okay. If you have a negative, so this will still say that this is 7 long. It's just negative because we are on the negative side of the x-axis. To find the missing side that you're going to need, your hypotenuse, to fill out 4 of these 6 trig ratios, you're going to have to do the Pythagorean theorem. So 3 squared plus 4 squared equals c squared. So 9 plus 16, 25 equals c squared. Take a square root, and in this case, c is 5. Now that we know all 3 sides, it's just a matter of labeling opposite, adjacent, hypotenuse. The angle t, in this case, sometimes theta, is always the one that's near the origin when you're doing these. So this would be t right there. So the opposite side will always be your y. So here's your opposite. Here's your adjacent, and here's your hypotenuse. And then you just fill them in. So sine, let's make this a little tinier so I don't have to squeeze it in, is opposite over hypotenuse, so 4 over 5. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Cosecant, secant, and cotangent are just the reciprocals of the 3 trig functions that we use more often. So we're just going to take these and flip them upside down. So it'd be 5 over 4, 5 over 3, and 3 over 4. All right, let's do just one more just so that you guys get the full flavor, and we can talk about what happens if you have radical hypotenuses. I'm not sure. So our x is -7, our y is 1. We're going to use the Pythagorean theorem to find the missing side. So -7 squared is +49, plus 1 squared is 1, is c squared. So c squared is 50. Then we're going to take a square root. If you don't know how to simplify the square root of 50 by factoring and finding repeated factors and factor them out of the radical, go ahead and throw that thing in a calculator, because you don't want to write c as radical 50. That's correct, but lazy. The same way that 6 over 8 is lazy. There's just a maybe more reduced form we could write it in. You can also write this as 5 radical 2. Okay, so we have 5 radical 2. Now we need to write our sine, cosine, and tangent. I'm going to actually make these a tiny bit bigger just so that I have some room to do the rationalizations. So for sine, this is going to be opposite because we're going off the angle nearest the origin. So 1 over the hypotenuse, 5 radical 2. Now, we're not allowed to leave radicals in the denominator. So what we do to rationalize that is we multiply the top and the bottom by the radical. So on the top, 1 times radical 2 is radical 2. On the bottom, radical 2 times radical 2 is 2, and it's being multiplied to the 5 that's already there. So 5 times 2 is just 10. So we'd want to write this as radical 2 over 10 as opposed to 1 over 5 radical 2. Cosine is going to be adjacent, which is -7 over 5 radical 2. Rationalizing is going to be -7 radical 2 over 10. And then tangent is opposite over adjacent. So it's going to be -1 over 7. Then for these, we just do the reciprocal. It's nice to have these unrationalized forms because if we do the reciprocal of these, they'll come out rationalized. If you reciprocal these, you're going to have to rationalize again, which is kind of a pain in the butt. So if I flip this over, it would be 5 radical 2 over 1, but we don't need to write over 1. Cosine being flipped for secant would be 5 radical 2 over -7. And then tangent is going to simplify to just -7. And that's how you are going to find the exact value for your trig ratios, given some random angle with a goofy endpoint. Okay. Let's do one application problem. Then there's something that I've thought of that I want to just briefly touch on, and then I'll show you a pretty picture that I drew. You'll see when you get there. So here we have an application problem. In general, for application problems, your goal is to make a right triangle and then set up trig ratios and hopefully solve it. Okay. This one is a little bit weird because if you set up the triangle, it's not immediately obvious how you solve it. So there's a little extra know-how that goes into this one that I want to remind you about. So this says we have a 6-foot tall woman standing 12 feet from a lamp. So I'm going to just go ahead and fill this in as 12 feet right there. Apostrophe means feet. So from here to the woman is 12 feet. And she casts a 8-foot long shadow. So this shadow right here, that's 8 feet. We want to know how tall is the lamppost. We're looking for that height. So if we look carefully, we can see that we actually have 2 triangles here. We have one triangle made of the woman, her shadow, and then an imaginary line drawn between the 2 of them. That's one triangle. The other triangle that we have is from the top of the lamppost down to where the shadow's head is, the distance between the shadow and the lamppost, and then the height of the lamppost. So what these 2 triangles have in common are, actually let's do maybe red. This angle, because you can see there's the tiny one, there's the big one. They're literally the exact same angle. They're made the same way. They're in the same spot. They overlap. They're the same. And this angle here is a right angle. Because of the way triangles work, that implies that these 2 angles are also the same. So any 2 triangles that have all 3 matching angles are what are called similar. If you have similar triangles, sine of theta should equal sine of theta for any 2 similar triangles. So let's throw some numbers on this and I'll show you why that's important. Here, side note, cosine is also equal, so is tangent. All the trig ratios should be equal for similar triangles. So for the woman's triangle, this side is 6 feet tall, because she's 6 feet tall. Her shadow is 8 feet long. And we're going to avoid doing Pythagorean theorem as long as we can. For our lamppost triangle, the lamppost, we don't know how tall that is. It's h. And the distance from the bottom of the lamppost to the top of the woman's shadow is 12 and 8 more feet, so 20 feet. If we set up the tangent of this angle right here, theta, we know they're equal because they're similar. So tangent of theta equals tangent of theta. Tangent of theta for the blue triangle is 6/8. Tangent for the green triangle is h/20. This is a really easy equation for us to solve. So what we're going to do is we're going to just multiply 6/8 by 20, right? Multiply both sides by 20 to isolate h. And we're going to get the h equals, put this in your calculator or however you want to best solve it. You could reduce 8 and 20 is, how many times does 8 go into 20? A few, right? We could reduce this to 3/4. 4 goes into 25 times. 5. So it's 3 times 5. So this is 15 feet. So the height of our lamppost is 15 feet. Not too bad. So this is, I think, maybe the only really weird thing about triangles you might have forgotten. The rest of the word problems are pretty much, here's a thing is like a lighthouse, right? Here's your lighthouse. This distance, we don't know. This distance is 150. This angle here is 4 degrees. Set up a trig ratio and solve for the unknown. It's not too bad. You'll figure it out. All right. So there's our application problem. Let's go ahead, take a breather. Feast your eyeballs upon this beautiful picture I made. Bam. I spent a bunch of time drawing that yesterday. Or today, rather. Yesterday for you guys watching, today for me. But Or maybe years ago for those of you in the future. Anyway, no copyright intended. This is a fan art. He's a handsome little fella, huh? All right. There's one thing that I feel I may have neglected in this set of notes. It's just some vocabulary. Let's talk about it really quickly. What color are we drawing? I don't like that one. Let's do purple. All right. If I have some angle, let's just look at this one right here. There is a thing called a reference angle. And what a reference angle is asking for is the distance in degrees or radians from the terminal side, which is the one that's not laying on the x-axis, to the nearest x-axis, reference angle. So the nearest x-axis to this terminal side would be this one right here. So what they're looking for is this blue angle I just drew. That's a reference angle. What you want to ask yourself is, how much farther do I need to go to get to the x-axis? If our terminal side were maybe not here, ooh, that's a little small. What if our terminal side was a little bit farther down? What if it rotated past the x-axis to, let's say, maybe here? Now it's gone too far. This is still the closest x-axis, and this is still our terminal side. So then you want to ask yourself, how far back do you have to go to get back to the nearest x-axis? So a reference angle is just asking how far is the nearest x-axis. This angle will always be positive. Always be positive. So even though we're kind of saying, oh, well, you go backwards, that should be maybe negative 60 degrees. Just take the absolute value. It's 60 degrees. Okay. Those are reference angles. You might see those on your homework. So if you have any more questions, or there's some other glaring vocabulary issue that I've missed, go ahead, hop in the WebEx, say, hey, Mr. Barton, you didn't do a good enough job on that video. Otherwise, have a wonderful day. Go tell your parents you lived. Say, Mom, I'm home. My math adventure was wonderful. I lived, I learned something. Maybe I didn't learn anything, but I reviewed something, I remembered something. How great is that? Have a great day, you guys.